Okay, so let's look I suppose, the big one, or one of the big ones, maximum and minimum problems. So again, if we're looking at applications of differentiation, as I kind of said in an earlier one, we were looking at the stationary points. This is kind of one of the key areas for the applications, and I suppose one of the big questions or big ways that this can be asked. So important that you know what's in the box there. So what happens at a maximum turning point? What happens at a minimum turning point? How can I prove what one I have? And when we're being asked to find a value that maximizes or minimizes a function, we're being asked to find maximum or minimum turning points. Okay, by and large, maximum or minimum turning points are going to be the values that will maximize or minimize the particular function that we have. So in order to solve these problems, the first thing we can do is draw a diagram. And it seems a bit kind of pointless if you like to say that, but in fact that can actually be really helpful to draw a quick diagram of the question that we're looking at. The next part then would be to write an expression in one variable for the quantity to be optimized. So for example, if we want to find the volume or we want to maximize the volume, we need to have an expression for the volume in terms of t, if it's with respect to time. So making sure we know from the question what quantity do we want to optimize and what variable with respect to. So if the equation is two variables, we might have to use some other sort of information either given to us or from our own knowledge to rewrite that quantity in terms of the other variable. We're going to then differentiate, set equal to 0. From then on, we're kind of following the same rules we use for stationary points. Solve to find the x value, use the second derivative to get the nature of each turning point, and then substitute that into the original function to find the maximum or the minimum y value. What I've said here, and I think it's quite important just to make note of, is when we're doing these maximum and minimum problems, it's just important that you use any relevant formula. So it could be from coordinate geometry, it could be from trigonometry, it could be from area and volume, we might have to use Pythagoras. It's just important that you're prepared to use those formulas so that you are able to find those. Because as I say, we might have to use information that's given to us, but the information may not be given to us, and we have to be prepared either way. So let's go through quickly some of these examples, then we'll jump through some exam questions just to get you some familiarity and just so you can see the sorts of questions you get asked. So this, again, a common enough one here as an example. It's about a sheet of cardboard. It's a square sheet of cardboard measuring 40 by 40. So if I do a little quick sketch here, so 40 by 40 here. They're making a box, so they cut squares of side length x here from each corner, and the sides are then folded up to form a box, an open rectangular box. Okay, the sides are then folded up so that we form an open rectangular box. So looking at what I have here then, I'm going to take the 40 obviously as being the full length, and if I'm looking at just this small length here, that's 40, take away 2x, an x from each side there. Similarly here, 40 take away 2x, 40 take away 2x. So looking at my length, my width, and my height, then my length of my box, 40 minus 2x, my width, 40 minus 2x, and the height of the box, if I'm folding it up in that way, from kind of the corners, folding it up, the height of the box is going to be the x that I've cut out. So to find the volume, it's going to be x, x multiplied by 40 minus 2x multiplied by 40 minus 2x. Okay, so multiplying this one out, just making sure we kind of take it slowly, I suppose. So 1600 minus 160x plus 4x squared, and then multiplying across by x gives me 1600x minus 160x squared plus 4x cubed. If we want to maximize this, we need to get the second derivative and we need to put it equal to 0. So let's find the second derivative first of all. Gives me 1600 minus 320x plus 12x squared. We're going to be setting that equal to 0, so let's take the equation here, 12x squared minus 320x plus 1600, putting it equal to 0. Let's divide across by 4, just to make it a little bit nicer for us if we can. 400 equals to 0. So I'm looking for two numbers that would multiply to give me 1200 and add to give me 80, okay? So if I'm reducing that down straight into my brackets, I'm just going to go straight to the answer here, I suppose, because obviously we want to prioritize using our time here to look at the questions rather than factorizing quadratics. All good skills. It's always important just to be building on these skills, making sure you're keeping yourself competent at them. But we're just going to keep ourselves going here. We're going to find the second derivative now to determine out of these two values, which is giving me a maximum and which is giving me a minimum value. So I need to find my second derivative. So that's going to be 24x minus 320. So when x is equal to 20 over 3, let's sub that in. So 24 over 20 over 3 minus 320. Let's use my calculator here. So 24 times 20 over 3 minus 320 gives me minus 160, which of course is less than 0, which implies that x equals 20 over 3 is maximum, gives a maximum value. Okay, then using my other point here, so I'm going to be doing, let me see, it's going away on me, 24 times 20 minus 320, and substituting that in gives me 160, which of course is equal to 0, which gives me then that x equals 20 gives a minimum value. Now I've been asked to find an expression for the volume and hence find the maximum volume. So I'm going to be taking my maximum over here. I'm going to find my volume at that value of x. So subbing back into, I suppose, my original equation here. So the 1600 times 20 over 3 minus 160 times 20 over 3 squared plus 4 times 20 over 3 cubed. That's going to give me an answer of 128,000 over 27. Okay, have we been given any units? We have, so we make sure we include our units as well. Centimeters cubed. Always important to include our units there. It might only be 1 mark, but 1 mark's worth having. Okay, particularly if it's just for units. It's a shame to lose a mark for just forgetting a unit when the units were in the question. Let's look at another example then to see again just another way it could be asked. A sector of a circle with radius or an angle theta measured in radians has area 100 centimeters squared. Find an expression for the perimeter and hence find the value of or that minimizes the perimeter. So let's look at let's sketch our diagram of what we're looking at. Sketching the diagram always is quite helpful, to be quite honest. So sketching my diagram, I'm looking at a sector like this with angle theta. It has radius or, which would be these two parts here. So immediately I can see that to use the information they've given me or to look for what they've told me here, I need to find an expression for the perimeter, and then I'm going to be minimizing the perimeter with respect to or. So I need to find dp dor. So I need my perimeter in terms of or. At the minute, my perimeter would be equal to or plus this yellow part here. Now the yellow part here is an arc. It's an arc for my sector, and we should hopefully remember that the length of an arc, if my angle is in radians, is just or theta. Okay, where theta is in radians. So at the minute, that's what I have. Okay, the length of my arc, or plus or theta. Now my perimeter there looking fine, I suppose, but I don't want theta. Theta is kind of the problem part here. So I need to look back at my question, see what other information I have. I'm told the area of the sector is 100 centimeters cubed or squared. The area of a sector when my angle is in radians is a half or squared theta. And I know the answer here, of course, is 100. So if I use this information then, that gives me that or squared theta is equal to 200, and theta is 200 over or squared. Taking that then back with my perimeter at the minute is or plus or theta, which of course now is going to be 2 or plus or times 200 over or, which is then 2 or plus 200 over or. 2 or plus 200 over or. Okay. So continuing on then, if that's my perimeter, I want to find my first derivative for that. So the 2 or goes to 2. If we remember here, I can rewrite this as 200 or to the power of minus 1. So that's going to be minus 200 or to the power of minus 2. Minus 200 or to the power of minus 2. Now I want to solve that equal to 0 to find a maximum or a minimum turning point. I'm trying to minimize the function. So or to the power of minus 2. Okay, so let's just rearrange this one a little bit. I'm going to put the r squared on the bottom here. So remember, r to the minus 2, I can put it back down in the bottom again. I'm going to multiply across by my r squared there. And I'm going to actually bring everything back over to one side. I'm going to divide across by 2. And I should recognize this then as a difference of 2 squares. So r minus 10 or plus 10 equals to 0, which means that my radius is either 10 or minus 10. Of course, it can't be minus 10 because I can't have a negative value for my radius. So my radius is going to have to be 10. So we want to check that that is going to give me a minimum, that's going to give me a minimum value. So let's just find the second derivative for my perimeter. So that's going to be 400 or to the power of minus 3. So 400 over 10 cubed, which of course would be 4 over 10, which is greater than 0. So it gives me a minimum. And I was asked to find the value of r, not to find the minimum perimeter. So therefore, r equals 10 gives a minimum. Gives me a minimum perimeter. And that's the main thing we want there. Okay. So 2 nice examples there. So let's get stuck into the exam questions, I suppose. So a rectangle is inscribed in a circle of radius 5 units and center 0, 0 as shown. Let or xy, where xy are elements of or the real numbers, be the vertex of the rectangle in the first quadrant as shown. Let theta be the angle between O or and the positive x-axis, where theta is between 0 and pi over 2, so 0 and 90 degrees. The point or can be written as a cos theta, b sine theta, where a and b are elements of or. Find the value of a and the value of b. Find the value of a and the value of b. Okay. So let's have a look at this one, I suppose. So looking at the example that I have here, I have my angle theta and I have my value 5 here as well. So if we look at it in terms of a kind of nice triangle for ourselves here, we have x in this position here, and we have, or sorry, not x in this position, we have y in this position, we have x in this position, x being how far across I need to go to get to my point or, y being how far up I need to go to get to my point or. So taking that part out on its own, I have 5 here, I have y here, I have x here, and I have theta here. Okay, if I'm going to be rewriting this point using this idea of a cos theta, I'm trying to show that x is the same as a cos theta and that y is the same as b sine theta. So I should hopefully know that cos theta would be adjacent, which is x over hypotenuse, which is 5, which gives me that x is equal to 5 cos theta. Similarly, sine theta is opposite, which is y over 5, which means y is 5 sine theta. So therefore, both a and b are equal to 5. Okay. Next off, we need to show the area of the triangle measured in square units can be written as a theta equals 50 sine 2 theta. So let's have a look at this one here. So looking at what we have, this rectangle here, we would need this length and we would also need this length here. Now, comparing or using the points that I know that the x value that I've gone across here, we've written it down as 5 cos theta. Okay, we've written this down as being 5 cos theta. So we know that this is also 5 cos theta. So to go the full way across here in the yellow will give me 10 cos theta. Similarly for the pink part there going up the way, it's 5 sine theta, and this is also 5 sine theta. So to go the full way up there, it's 10 sine theta. Okay, so we know 10 sine theta there. So let's break it down. So the area, of course, would be length by width, which would be 10 cos theta by 10 sine theta, which is going to give me 100 cos theta sine theta. Now, one of my trig identities that I should be able to find in my log tables is actually that 2 sine theta cos theta is equal to sine 2 theta. Okay, so I'm recognizing from the question here that I need to use a trig identity to find sine 2 theta, because that's kind of one of our multi-angle formulas. So sine 2 theta are not multi-angle, kind of double angle formulas. So let's rewrite our question here as 50 times 2 cos theta sine theta, which is going to give me 50 sine 2 theta as required. So next off, we need to use calculus to show that the rectangle with maximum area, so maximum area, dA d theta, dA d theta, I'm assuming, because my area is in terms of theta, and I want to show that that's going to be equal to 0. And showing that it's a square, I'm assuming something to do with the angles, or perhaps something to do with the values of r. Okay, the actual values of r that I get. So let's have a look. So I need to differentiate my area here with respect to theta. So we have to be careful with this one. So differentiating this angle formula, so area is 50 sine 2 theta. So to differentiate that one, I differentiate the sine first of all, and that goes to cos 2 theta. But I have to remember that I have to multiply by the derivative of the middle part here, which of course is 2. So that gives me an answer of 100 cos 2 theta. Okay, 100 cos 2 theta. Okay, I want to know now where this function is going to be equal to 0, where this is going to be equal to 0. So I'm looking to find where cos 2 theta is equal to 0, where cos 2 theta is equal to 0. So thinking about our trig kind of equations that we had here and our cast circle and all of that. So it starts down here, cast. Okay, starting that kind of way, working our way around. So making sure that we kind of know what's happening in all cases there. So where they're positive, where they're negative, and so on and so forth. So they're all positive in the first section. If I want cos 2 theta to be equal to 0, well, I'm not getting much of a, I suppose, a reference angle, if you like, but let's go with that. So let's say cos of my reference angle equals 0, which means that my reference angle is equal to cos inverse of 0. So let me just make sure my calculator is in radians. Cos inverse of 0 is pi over 2. So that's going to tell me that 2 theta is equal to pi over 2, which means that theta itself is equal to half of that. Okay, so pi over 4. Now, am I correct in using radians for this one? Yes, theta was between 0 and pi over 2, so pi over 4. So we know theta now is pi over 4. Theta is pi over 4 in this case. I know I drew out my cast circle, but because it's equal to 0, we're not having to do a lot of those calculations there really. Just using our reference angle to make sure we remember to kind of divide by 2 in that case as well there. So to show the maximum area as a square, well, we need to look at, I suppose, the lengths of the sides. So let's look at the length. The length was 10 cos theta, if I remember correctly. Yes, or the width was 10 cos theta, I suppose, and the length was 10 sine theta. And subbing in that value for theta, I'm doing 10 cos pi over 4, and I'm doing 10 sine pi over 4. So 10 cos pi over 4, cos of pi over 4. Oh, what's happening here? Cos of pi over 4 is going to give me 1 over root 2, so 10 over root 2, and sine of pi over 4 is also going to give me 1 over root 2, so 10 over root 2. So length equals width, so therefore we get a square. So a square, obviously, as we know, is a rectangle where the length and the width are equal. Okay, so the length and width are equal, where they both have the same value, the 10 root 2 there, or we could, in fact, probably simplify that down to 5 root 2 for both of those. Okay, but the same idea holds, just making a note that that is a square because both sides are equal. Find this maximum area. Well, we sub that value of pi over 4 back into my area formula, which we know was 50 sine 2 theta. Theta here being pi over 4. Just double check we have that correct. We do. So 50 times sine 2 times pi over 4. And that gives me an answer of 50. Now, do we have any units for that one? 50. We do not, so let's just say units squared. Okay, So a lot going on in that question there. We can see pulling in bits of trigonometry with our trig functions as well, using bits of kind of coordinate, or I suppose it is essentially trigonometry with your circle as well, your unit circle, pulling in all of those ideas that maybe just wouldn't be as familiar or as recently used by us. So just making sure we're still remembering all those ideas, I suppose. Let's look at the next question. So I suppose some of these questions fairly long. We have another question or two that we can have a look at. So two ships set sail at the same time. Ship A from port A and ship B from port B. Port A is 90 kilometers due west of port B as shown below. Ship A is traveling due east at a speed of 15 kilometers per hour. Ship B is traveling due south at a speed of 30 kilometers per hour. Find the distance between the two ships 30 minutes after they set sail. So let's focus on ship A first of all. So after 30 minutes, so 30 minutes of course being half an hour, if it's going at 15 kilometers an hour, then it will have traveled 7.5 kilometers in half an hour. 7.5 kilometers in half an hour. Similarly, ship B is going at 30 kilometers an hour, and we're going to multiply that by half, and it will have traveled 15 kilometers. Let's draw a little sketch then of what we're looking at. So ship B here, ship A here. So ship B has traveled 15 kilometers, ship A has traveled 7.5 kilometers, and we're going to use Pythagoras then to work out the distance between them. So h squared equals 15 squared plus 7.5 squared. So let's work that out. So 15 squared, 225, 7.5 squared is 56.25. 56.25 there. Or excuse me, I'm jumping too quick there. 7.5, of course, being the distance A has traveled, does not mean that that is the distance from my top here. I need to make note of the 90 kilometers here as well. So yes, I have traveled a distance here of 7.5 kilometers, which would mean that I have a resulting distance left to get to port B of 82.5 kilometers. I was thinking that was a bit small for us there. So I have 82.5 kilometers left to travel to take me to port B. That fits in a bit more with what we might expect for a question, I suppose, of this length, if you like. So that will give me 6,806.25. So adding that together with my last answer gives me 7031.25, which means h is the square root of that. And taking the square root of that answer gives me two decimal places as h being 83.85 kilometers. So a distance of 83.85 kilometers between them. T is the time in hours after the ship set sail. Show that the distance between the ships at time t can be given by the function, by this function, where t is between 0 and 6. Okay, so a lot to break down here, a lot to kind of talk through. T is the time in hours after the ships have set sail. We're looking for the distance. We should know that the distance between the ships, as we've kind of worked out there, it comes down to Pythagoras in the end, but we need to also include the distance between ship A and port B here, and then the distance between ship B and port B. So this is the distance traveled by B. And this top one, as we saw in the last part, is 90 minus the distance A has traveled. Okay, so let's work out kind of expressions for these distances. So the distance traveled by A, so distance we should know is speed multiplied by time. So depending on the time that, and assuming that t is in hours here, then we're told t is the time in hours, then the distance traveled by A is 30t, and then that means that our distance along the top of our little triangle here, so our pink distance here, is going to be 90 minus 30. What speed is A going at? A is going at 15. So 90 minus 15t as our pink section here of our triangle. Then the distance that B has traveled is the speed B is traveling, which is 30 by the time that it's traveling. T, the time it has traveled. Fairly a little bit more straightforward there for B. Okay, We need to use this now to find the distance between A and B at all times. So let's have a look. So that's going to be, that distance squared is 90 minus 15t squared plus 30t squared. So let's look at this one. So 90 squared is 8,100. 90 times 15 is 1,350. I'm going to multiply that by 2 to get 2,700t. And then 15 squared is 225. T squared plus 30 squared is 900. T squared. Okay, I feel like we're getting somewhere. I can see some of these answers are kind of coming up as expected there. So adding all of this together, I get 1125 t squared minus 2700t plus 8100. Obviously that's it squared. So to undo that, I'm going to take the square root, and noting the way they've asked us in the question, we're going to use the same notation, making use of the fact that a square root is the same as a power of a half there. So the distance from A to B is 1125t squared minus 2700t plus 8100, all to the power of a half. Okay, tricky elements now to that question there. We now need to use calculus to find the value of t when the ships are closest to each other and find the distance between the ships at your value of t. Okay, so thinking about what this means, ships being closest to each other, what we're trying to do is we're going to minimize the distance, s of t. We need to get the minimum, the smallest distance there. Okay, so let's write down our function s of t then for ourselves. So it's 1125t squared minus 2700t plus 8100, all to the power of half. Okay, I want to find the derivative of this, and we need to make sure as well that we note that the derivative of this part requires a bit of a chain rule. I'm focusing on the power, and then I'm doing the section on the inside of the brackets then. So let's focus on the power first of all. So that would be half times my brackets here. We're going to have quite a long expression here, I can tell already. 8100 to the power of minus a half. Okay, to the power of minus a half. And we're going to multiply by the derivative of the middle part, which gives me 2250t minus 2700. Okay, so looking at this equation, then I need to set that equal to 0 to find my minimum value. And we can actually kind of simplify this one. We might think that we need to, I suppose, multiply this whole thing out, but in fact that's not going to save us an awful lot of time here to multiply these equations out. So what we're going to do instead is we're going to kind of take the, I suppose, separate aspects of this here. So let's just kind of rewrite, rework, see what kind of, I suppose, works out the best for us in this case. So 2250t minus 2700 all over 2 to the square root. We'll use our square root notation this time. 1125t squared minus 2700t plus 8100. And I want to put all of this equal to 0. So what I'm going to do to save myself, I suppose, a little bit of trouble here. So what I'm going to do is I'm going to multiply across by the denominator that I have there. Okay, I'm going to multiply across by the denominator to completely eliminate that denominator. So that's going to give me 2250t minus 2700 equal to 0. Let's divide across by 2 there. 1125t minus 1350 equals to 0. So t is equal to 1350 over 1125. And let's see, does that break down to anything smaller for us? 6 over 5 or 1.2. 1.2 hours. Okay, so after 1.2 hours, my two ships are as close as possible as they are going to be. So let's find the value or the distance between them at that time of 1.2 hours. So I'm looking at 1125 by 1.2 squared minus 2700 by 1.2 plus 8100, and I'm putting all of that then to the power of a half. So let's work this out. We maybe take it in a few steps here. So 1.2 squared, multiply that by 1125. 1620. 2700 by 1.2 minus 3240, and then plus 8100, and all to the power of half. So simplifying down, 1620 minus 3240 plus 8100 gives me 6480. Still to the power of half, I need to take the square root of that or put it to the power of a half. So 6480 to the power of a half, let's do power of a half this time. I get 36 root 5, which is approximately equal to 80.5. I think it was 1 decimal place, wasn't it? Yeah, given kilometers correct to 1 decimal place, so that's approximately 80.5 kilometers. Okay, again, similar to the first question there, a lot happening with that one. A lot of complicated looking things. I suppose this first part, the speed and the distance and using all of that, a little bit tricky to set all of that up. So just kind of to make sure you're kind of really thinking through all of the parts of this. And definitely, as I say, setting up those first few parts are a little tough, a little trickier to look at there. Let's look at this next part. So a stadium can hold 25,000 people. A stadium can hold 25,000 people in it. Okay, people attending a regular event at the stadium must purchase a ticket in advance. When the ticket price is €20, the expected attendance at an event is 12,000 people. The results of a survey carried out by the owners suggest that for every €1 reduction from 20,000, the expected attendance would increase by 1,000 people. If the ticket price was €18, how many people would be expected to attend? So we know at €20, we're expecting 25,000. We're saying that if we decrease that by 1, we'd expect 1,000 more people. Okay. Sorry, 25. It can hold 25,000, but we were only expecting 12,000. If we decrease it, we'd get 1,000 extra. If we decrease it now by another euro, we should get another 1,000 extra. So we should get 14,000 people if we decrease it by €2. If we let X be the ticket price, okay, if we let X be the ticket price, where X is less than or equal to 20, write down in terms of X the expected attendance at such an event. Okay, attendance, I assume from that we're looking at the kind of price or idea that we might get there. So if we know that the ticket price depends on kind of, or has an impact on the number of people that are going, and we know that depending on the ticket price, if we reduce the ticket price by 1, for example, then I will get an increase of 1,000. I want to relate that to the value of X. So I'm looking at my ticket price as being 20, take away X. So X is my new ticket price. And that's going to be multiplied by the 1,000. That's the addition that I'm making to the attendance. And I'm adding all of this to the initial attendance. So this is my initial attendance, or the kind of original attendance, if you like. This middle part here is accounting for the reduction in price. Okay, this is accounting for the reduction in price. So if the price is 19, then 20 minus 19 gives me a value of 1. And I'm adding on an additional 1,000 people. So that's like my additional people. Okay, writing down a function in f that gives the expected income from the ticket sales at such an event. Well, let's look and see. So the ticket price, when the ticket price is €20, we get that expected attendance. If we reduce it by 1 from €20 in the ticket price, the expected attendance would increase by 100 people. So if this is my attendance then, to get the earnings or the income that I would make from that, I would need to multiply this attendance by the price. So let's first of all, I suppose, start here by maybe simplifying out the attendance formula if we can. So 20 by 1,000 gives me 20,000 minus 1,000x. So 32,000 minus 1,000x. Minus 1,000x, and to get the income I need to multiply attendance by price, making sure that we're noting here the price in this stage now at where we've kind of got to with the question is not even 20 but is in fact x, because we're accounting for the fact that the price is variable if they want to increase the number of people going. So my income here, and they're calling it f, so f of x is 32,000x minus 1,000x squared. Find the price at which the tickets should be sold to give the maximum expected income, maximum first derivative f dash x equals to 0. Let's have a look. Let's find the first derivative of this function here. That's going to be 32,000 minus 1,000 or minus 2,000x. Putting that equal to 0 gives me 2,000x equals 32,000, and x then equals to 16. So 16 euro we're suggesting will give the maximum. Let's just double check, I suppose, that that is a maximum. Minus 2,000 less than 0, therefore x equals 16 gives a maximum. Now to find this maximum expected income, we sub 16 into our f of x there. Okay, and subbing that in gives me a value of, where's my calculator gone? squared gives me a value of 256,000 euro. 256,000 euro. Okay, so last question there again, just pushing us that little bit further, making sure that we can kind of now, I suppose in that one, there's a lot of kind of word equation nearly coming to the fore there. So being able to write a word equation, being able to structure it, being able to make changes to the word equation according to the information we're given. The actual working out the maximum and using the calculus there comes in near the end. And the calculus itself isn't too hard. It's the setting up of the equation that could be quite difficult there. And not even overly difficult, but just to watch out for. It's just kind of thinking through it. But we can see there across those questions, all very different. And the maximum minimum parts are the same for a lot of them. It's the structuring the question in the first place, building it all together and kind of following through from that extent that can be tricky, that can be difficult. So it is just making sure that, I suppose, obviously you know those initial parts that we said, but also that you're following those steps, keeping any formulas in mind that you might need, solving for the x values, always checking for the y values or the value that gives the minimum or the maximum as required in the question. Because it's just making sure that, I suppose, in all those cases that you're definitely answering the question that they have asked of you.